All right, guys. So we are talking about urbanization and urban runoff. So first and foremost, what is urbanization? This is probably the worst definition of urbanization in the whole entire world. It's the process of becoming more urban. Right? Like, I don't know who decided that was a good thing to write down, but there it is. For lack of a better term, or in place of a better term, urbanization is taking natural land and building on top of it. It's developing natural land. Yes.
Are we done with the irrigation notes?
Yep, we're done with the irrigation notes. Yep. So my dad actually grew up in Lehigh. He grew up in Lehigh back in the day. Okay, this is not going to tell you a little bit too much about my dad, but so it was like Farmville when he lived here, and him and his friends were kind of idiots, like in the lovable sense. And they would take like their pickup truck down Lehigh, Maine at like 2 a.m, and they would take old tires and they would just huck them out of the back of the truck and let them roll down Lehigh, Maine. Which, like, if you did that now, you'd get arrested. But back then, it was funny. So, if you want to look at this, like, Lehigh, when my dad lived there, was probably like this, right? Lots of rural zones, lots of farms and stuff. Where I live in Lehigh, it looks more like this. So, kind of in between, like, an urban zone. But Lehigh is transitioning into something that looks more like this because we have high density housing, right? We have a lot of people living in a small area because Lehigh is becoming this hubbub of a cool area to go live in. Can't believe I just said hubbub, but we're just going to move on from that. But as you look at like different parts of Lehigh, like the outlets, and if you look at the Meadows, which is a shopping center, which it really should not be called the Meadows because it was built on a swamp. And if you look at the sign, it has like water plants on it, so it doesn't make any sense it's called the Meadows, but that's just a DeHart beef. It looks more like this. So we're getting more and more urbanized as we go, and as we have more people move to Lehigh. So why is the study of urban areas important? This is not in blue, so you do not need to write it down, but just good things to know. So approximately 84% of the U.S. population lives in urban areas. And so in 1950, it was at 64%. So we are going up by 20%, which is like huge, right? We are having more people live in urban areas. And by 2050, almost 90% of the U.S. population is going to be living in urban areas. And so if you look down here, it says the rate of urbanization is increasing. So you guys were all born, I'm going to say like 2003 to 2005, right? That's your guys' birth age area. So in your lifetime, so from 2000 to 2050, our urbanization is going to increase by 300%. It's going to triple. So we're going to have so many more urban areas. And then this is like the biggest takeaway that I want you guys to remember is that stormwater runoff from the built environment is the principal contributor to water quality impairment of bodies nationwide. So the biggest perpetrator of water pollution nationwide is stormwater runoff. So runoff from urban areas, which is insanity. Moving on from there, urban metabolism. If we look at urban areas tend to take more than they give. So if you look, the things that urban areas need, whoa, didn't want to do that. That's what I get for messing around with this. There we go. Urban areas, they usually take like food, energy, materials, and water. And the only thing that urban areas ever give back are wastes, biological waste and non-biological waste. So that's kind of a downfall, especially because ecosystem services, natural areas give things back, whereas urban areas do not. So we're going to talk about the ecological footprint of urban areas. So urbanization can lead to a depletion of resources in an area. The weird thing about urbanization is that urban areas use more land than they seem to use. So if you look at 1 square kilometer of urban area, it actually requires 18 square kilometers of forest, 50 square kilometers of agriculture, and 133 square kilometers of marine. So for every square kilometer of urban area, we are using about 200 square kilometers of land to support it, which is insanity, right? That's so much land. And the scariest thing about that is if you look at this over here, that a waste assimilation footprint is at least twice as large as that for consumption. So if we are using 200 square meters of land to support an urban area, we are creating 400 square meters of waste for 1 square meter of urban area, which is like so crazy. So an ecological footprint then is the comparison of the resource demands and the waste production. When we talk about sustainability, you guys are all going to be looking at your own ecological footprint and see if everybody lived the same way you did, how many earths we would actually go through. So some things that go into an ecological footprint are forest products. So like how many things do you use from the forest? How much timber do you use? How much space do you use? We have our carbon footprint, which is like emissions, energy usage, things like that. We have cropland and pasture, looking at your diets. So depending on what food you're eating, you're going to have a different impact on the environment. Built up land, talking about urbanization. So like how much urbanization is going on, and then also fisheries, right? So how much of our water are we using for fish? Are you getting fish from a sustainable area? Things like that. And so when we look at urbanization, there are a lot of things that go into urbanization that you might not have thought about previously. I'm just going to scroll up a little bit. I'll still leave this on the screen so you guys can see it. So, bring that back down. Urbanization can change the hydrologic cycle. So the hydrologic cycle is just a fancy way of saying the water cycle, right? So hydrologic, hydro meaning water. So this is looking at how different areas, depending on how urbanized they are, how much infiltration, how much runoff, and how much evapotranspiration there is. So before we actually talk about that, let me explain what evapotranspiration is, because a lot of people probably don't know. I talked about this in my botany class, but basically evapotranspiration is plant sweat. So if we have our cute little plant over here, and there's the roots, right? It's a terrible color. Let's just do it in black. Okay, so here is our planty boy. It's got the roots. I know, right? So cute. Plants are really awesome because they actually have veins like we do. So their veins are called xylem, which is Xylem, and then we have phloem. Xylem goes up and phloem goes down. So xylem is what's in charge of taking water from the roots to the top of the plant. Inside of the plant's leaves, we have things called stomata, and they're little openings. And the point of the stomata is allow oxygen and CO2 to come inside of the plant and to allow for water to leave. So plants kind of work really similar to straws, which is like a really weird thing to think about. So the only way that we can pull water up a plant is if we start to lose water in the first place. So imagine this plant is a straw. You have to have this negative pressure up here where the water is in order to bring water through the plant itself. So the loss of this water right there, that's evapotranspiration. So when we're looking at these things over here, and it says like 40% evapotranspiration and like infiltration and stuff like that, that's what it means. So in an area that is natural ground cover, so absolutely zero impervious surfaces, we're going to have about 50% infiltration. So we're going to have 50% of the water that is being put on this environment is going to go to the soil, be filtered, go to like an aquifer, and then be used again. 10% is going to be runoff. So no matter what, there's no way you can actually stop runoff. Runoff is always going to happen. But then we have 40% evapotranspiration. So that is clean water leaving plants, going back into the atmosphere to be recycled back into the water cycle. When we have 10 to 20% impervious surfaces, you can see that our 50% infiltration is now 42%, because we have 20% shallow infiltration and 21% deep infiltration. Our runoff has doubled, so it has gone up by 100%, and our evapotranspiration has dropped 2%, so not a whole bunch. If we look at 30 to 50% impervious surfaces, you can see that our infiltration is now 35%. So where it was 50% before, we were down to 35%. Our runoff is now 200% higher than it was with regular, and our evapotranspiration has gone down. And if you look at 75 to 100% impervious surfaces, you can see that only 15% is going to be infiltration, 55%. So 450% more water is going as runoff, and then 30% evapotranspiration. So impervious surfaces are human-made structures that do not allow for water to reach the soil. leading to increased runoff, flooding, and water contamination. And like we're more concerned about the water contamination than anything else because that's what impacts us the most. Urbanization can lead to increased soil salinity and saltwater intrusion into freshwater sources. So why do we care about soil salinity? What do you guys think? Think of our cute little mung bean lab. Why do we care about soil salinity? Yeah.
Because if there's too much salt in the soil, then all the water is being sucked into the salt and not to the plants, and then nothing can grow there.
Perfect. So like if we have our ground right here, let me draw a cute little picture because I can. I'm going to go crazy with this, guys. You're going to be like sick of the fact that I can do this. So here is our ground, and we have our little plant here, right? So our plant's going to want to have the water go to it, but if we have a lot of salt in the soil because we had a lot of salt in the water is going to be drawn out of the plant, and then our plant is going to die. So that's why we care about salinization. It's really damaging to crops and plants, and so we need to be aware of that. I didn't want that. So urbanization can also change the carbon cycle. So it increases the amount of CO2 in the atmosphere. Urban expansion in tropics is responsible for 5% of the annual emissions from land use change, and then creation of new carbon sources on land such as buildings. So not only does urbanization affect our groundwater, but it also is going to affect the carbon cycle in general by creating things that use more fossil fuels. Don't forget, I'm just seeing what's next. We don't care about that. Okay, this is the end of our notes for today. So as soon as you are done, go ahead and put your notes away, and we're going to do our 4 questions.